So in a rectangle ABCD, the equations of the line AB is y is equal to x plus 3, the x coordinate of A is 2, the line AD is parallel to the line y plus x is equal to 3. If C has the coordinates 3, 0, determine part A the equation of lines AD, BC and CD, part B the coordinates of A, B and D, and part C the equation of the diagonals. So as we begin, we have been given the rectangle ABCD. So allow me to sketch this rectangle and follow the order of labeling: A, B, C, D. And also you have been given the equation of line AB. Line AB is y is equal to x plus 3, and also the x coordinate of A is 2. Remember, we write points in the coordinate form x, y. So x is 2 and we don't know y, so we use letter y. So the coordinates of A is 2y. Then the line AD is parallel to the line y plus x is equal to 3. So in that case AD is equivalent, but this is not the equation of AD, so it is actually equivalent or is parallel to y plus x is equal 3 to 3. This simply means that whatever is the gradient of this line will be equal to the gradient of AD. Therefore, and also the other thing you have been given is that the coordinate of C is 3, 0. Therefore, we need to determine the equation of the lines AD, then BC and CD. So from this case, let us get first for AD, we need to get the coordinates of A, and since we don't know y, therefore we can be able to determine it. Now, for our case, we have been given the equation of line AD. It simply means that we can be able to substitute the value of 2 into the equation y is equal to x plus 3. So when x is 2, what will be y? Y will be equal to x is 2, so y will be 2 plus 3. Therefore y is 5. Therefore A is 2, 5. And since we want to get the equation of AD, we can be able to, let us call this C bxy, and we need to get the gradient of AD. We were given that it is actually parallel to the line y plus x is equal to 3. It is much easier. For this line, we can write in the form of y is equal to mx plus a constant, which will be y is equal to minus x plus 3. Therefore, gradient of AD is minus 1. So that is the gradient. So we can be able now to get the equation of AD. So equation AD will be given by what? Change in y over change in x, which is equal to the gradient minus 1. So y minus 5 all over x minus 2 is equal to minus 1. We multiply through, so we shall get y minus 5 is equal to, multiply through by x minus 1, so we have minus x plus 2. So y is equal to minus x plus 7. So this is the equation of line AD. That is the equation for line AD. That is y is equal to minus x plus 7. Then from there, we can also get the equation of BC. Let us call BC have xy as a coordinate, and since BC and AD are parallel to each other, then it means they have the same gradient. In our case, the gradient is minus 1. Therefore, change in y over change in x, that means y minus 0 over x minus 3 is equal to minus 1. This will be y is equal to minus x plus 3. So this is the equation for line BC. Equation for line BC. This for AD. Y is equal minus x plus 3. We move on and we look the equation for CD. Equation of CD. Also, we need to say let D be xy. Since we don't know the actual values of x and y, we need to get the equation for CD. And actually this is also parallel to AB since it is a rectangle. Consider the properties of a rectangle. AB and CD are parallel to each other. That means the gradient of AB is equal to the gradient of CD, and the gradient of AB is 1. The coefficient of x is 1. So from there, we get change in y over change in x will be equal to 1. Therefore, we have y minus 0 over x minus 3 will be equal to 1. So in our case here, we get y is equal to x minus 3. So this is the equation for line CD. So far, these are the equations that we have. Equation 1, then we have equation 2, and equation 3 for AD, BC, and CD. We move on and we go to the next question, whereby it is we find the coordinates of A, B, and D. Allow me just to redraw. Let me redraw the rectangle. This is what we have, and here the equation is y is equals to x plus 3. Here the equation is y is equals to minus x plus 7, and here is y is equal to minus x plus 3, and CD, the equation is y is equal to x minus 3. So this will now help us to get the coordinates of each point that we have been given. So in our case here, this is 2. Then, and C is 3, 0. Therefore, we can get the coordinates of A. The coordinates of A. So we consider side AB and AD. AB and AD. Since A is common, so we are going to equate the two equations such that we are going to get the value of y, the value of x. Now, from the two equations, AD, we have y is equal to minus x plus 7, and the other one we can make x the subject, or we just substitute the two. We get y is equal to x plus 3. So we are going to equate the two equations such that we have minus x plus 7 is equal to x plus 3. So this will be the same as, take this to the right hand side. So we have 7 minus 3 is equal to x. Take this to the right hand side plus x. So that will be 4 is equal to 2x. Therefore x is 2. Now we substitute this into one of the equations. So y will be equal to 2 plus 3, which is 5. So the coordinates of A is 2, 5. Then from there we move on. Now we look at the coordinates of B. Now in this case we consider side AB and BC. B is a common point, therefore we are going to equate the two equations. That is, y is equal to x plus 3, and the other equation is y is equal to minus x plus 3. So we are going to equate the two equations. So we have x, since on the left hand side it is y, therefore we equate the right hand side, which must be equal. X plus 3 is equal to minus x plus 3. From here, take negative x to the left hand side, it will become x plus x, which is 2x. Then to the right hand side, take positive 3 to the right hand side, it will be 3 minus 3, which is 0. Therefore x is equal to 0. Therefore y will be equal to, substitute into one of the equations. Can take this equation and we substitute into it. Y will be equal to x is 0 plus 3. Therefore y is equal to 3. So the coordinates of B is x is 0 and y is 3. Lastly, we can now consider side. Since we want to get the coordinates of D, we consider side AD and CD or DC. D is common. Therefore, we are going to equate y is equal to minus x plus 7 and y is equal to x minus 3. So we have the two equations. We are going to equate them to find the values of x and also y. Therefore equate, we have minus x plus 7 is equal to x minus 3. Working it out, we have minus 2x is equal to minus 10. Therefore x is equal to 5. Therefore, we can get the value of y. Y will be equal to, since we have take one of the equation, x minus 3, 5 minus 3. So we have 2. Therefore, the coordinates of D will be 5, 2. In general, we have been able to find all the coordinates of A, B, and D. For A is 2, 5, B is 0, 3, and D is 5, 2. So we get to the last part of the question, whereby it says we find the equation of the diagonals. We need to find the equation of the diagonals. So already we have the rectangle, and allow me just to draw it. So A is 2, 5. Since the coordinates of B is 0, 3. For coordinate of C is 3, 0. And that of D is, that is 5, 2. Now we need to find the equation of the diagonals. The equation of the diagonals, we have diagonal BD, and the other diagonal is AC. So in our case here, consider diagonal AC and BD. So that is our aim. So we need to find the equation of AC, and for us to get the equation of AC, we need to find gradient AC, and gradient AC, we get change in y over change in x. So y coordinates 5 minus 0 over 2 minus the x coordinate 2 minus 3. We get 5 over minus 1, which is minus 5. So we need to say, let point xy be on line with either of the point A or C. We can take A, 2, 5. Therefore, we can get its gradient. Then finally get the equation. Now we are leading to equation. Change in y is y minus 5 over x minus 2 will be equal to the gradient of this line AC is minus 5. We multiply through by x minus 2, so we have y minus 5 is equal to minus 5 times x, that is minus 5x, minus 5 times minus 2, that is plus 10. Therefore, y is equal to minus 5x plus 15. So this is the equation of one of the diagonals. Also, we can consider the other diagonal BD. Also, we need to get the gradient BD, change in y over change in x. So we have 3 minus 2 all over 0 minus 5. We get 1 over minus 5. So the gradient is 1 over minus 5. From there also, we say let another point xy be on line with one of the points. We can take D, 5, 2. Therefore, from this particular point, we have to get the equation of BD. So change in y minus 2 all over x minus 5 is equal to minus 1 over 5. That is the gradient. So from this particular point, we can actually cross multiply. So we have y times 5. We have 5y minus 2 times 5, that is minus 10, it will be equal to x times minus 1 minus x minus 1 times minus 5 plus 5. Therefore, we have 5y is equal to minus x plus 15. We can actually write it in the form of y is equal to mx plus a constant. That will be y is equal to minus x over 5 plus 3. And that is the equation of the diagonal BD. So that's how we get the equation of the diagonals. Thank you so much. Remember to follow me on YouTube, Michael Samuel Teacher. Subscribe for more teaching videos. Thank you for watching.